Good morning, ladies and gentlemen. Welcome to this video that's going to be on tangents and normals. So it's called going off on a tangent because it's a derivative of the original conversation. Cool, huh? Now, we should remind ourselves what a tangent is. A tangent is the line connected to a curve, so it's this red one, at a particular point. We typically say that it's connected at A, at x equals A, and it has a first derivative equal to the slope of the tangent at that point. So let's say we have a tangent on a curve meeting at A. Its y value will therefore be f of A. That's how far we get up. The question is, then how do we find the equation of this tangent? And the way we find the equation of the tangent is pretty neat. So we find the equation of the tangent by just taking a random point on the tangent and calling it xy. The random point on the tangent, we call that point xy. Now, if we want to find the slope of this tangent, the slope of this tangent, m, is rise over run. So y2 take y1 over x2 take x1. You guys may remember this. Then our 2 points, our y2 can be that just straight y value there. Take y1 is take f of A over x2 take x1. Same pairing. There. Now what's neat is if we think about this as the slope of the tangent, so the slope of that green line, we know another way to find the slope of the tangent. The other way to find the slope of the tangent is to find the derivative of the original function at A. So m, the slope of the tangent, is also equal to f dash A. So we can say that f dash A equals y take f of A over x take A. Now, why might we do this? Well, very simply, we can go from here to isolate y. So I can write this as f dash A bracket x take A equals y minus f of A. And from there, hopefully you'll see that y equals, I'm not going to rewrite it because it's right here, that. So, this looks trippy, but we are used to seeing the equation of a line in the form y equals mx plus c. Alright, so m, here in this case, is f dash a. It's the instantaneous slope at A. That's multiplied by x. The take A comes in there from the little proof above, and then the plus c is effectively that portion and, well, the second part of that. But this is a shortcut way of finding the derivative. Finding the equation of the tangent using the derivative. I'll show you how it works. It's a good idea for these types to have a plan going in because there's quite a few steps. So let's say if we're asked to find the equation of the tangent to the graph y equals x squared plus 4x at 339. It's important to remember where we meet is the a value. So that x value is our little a. And the steps go like this. 1, we should find f dash x, so derive it. Calculate f dash a, this should be a number. Find f of a from the original function, should also be a number. Then we've got all the ingredients to put in here. We will have f dash a, and f of a. And then simplify if required. So I'll show you the simplify at the end. That's just basically tidying up any common factors. Sorry, like terms. Maybe common factors. Alright, so first of all, find f dash x. So you can also call it dy dx, but I won't. I will call it f dash x. We've chosen an easy one to get started with, 6x plus 4. Cool. Alright, if we go 6x plus 4 is f dash x, f dash a, where a is 3, is, well, 6 times 3 plus 4 is 22. Then we want to find f of a. So that's f of 3. So if we're looking at our steps, that's step 1, 2, 3. F dash 3 is 3 bracket 3 squared plus 4 lots of 3. That's what, 3 times 9 is 27, plus 12 is 39. Embarrassing if I get one of those wrong. Then we have all our ingredients to use this property to, well, find it. Y equals, now instead of f dash a, that's a number, so 22. Instead of a, it's 3. And instead of f of a, it is 39. All right, then expand, simplify. Y equals 22x. Then effectively 3 times 22 is what? Negative 66 plus 39. Oh, what's the gap there? 27. So it's going to be negative 27. And that is the equation of our curve, of our tangent. If you imagine this curve, which I imagine will be something like this, at the point 339, there is going to be a tangent very steeply. That tangent has the equation y equals 22x take 27. And that should always be a straight line, because that's how tangents work. They are straight lines at a particular point. All right, that's tangents. What about normals? Now, the normal line is perpendicular to the tangent. So if we have a tangent touching at A, we know that the normal will also touch at A, but will just be 90 degrees to the original tangent. And this means that if we find f dash A, that would be the slope of the tangent. But if we go minus 1 over f dash A, that gives us the slope of the normal. So we would say mn, or slope of the normal, is minus 1 over f dash A, because we know that the tangent is at 90 degrees to it, and we can find the 90 degree sort of, do you remember this from year 10, year 11? Meeting by doing the negative reciprocal, so minus 1 on the original. So our plan to find the equation of a normal line is very, very similar. It is find the derivative, sub in A to the original, then same equation required, but instead of f dash a in here, so instead of having that f dash a in there, our slope is not going to be f dash a. Our slope is going to be the negative reciprocal of f dash a. So put in minus 1 on f dash a. All right, so let's do it. Find f dash x. So f dash x is 6x plus 5. Easy. F dash a. F dash a is, well, 6 lots of minus 2 is minus 12, plus 5 is negative 7. F of a. Sub in minus 2, so 3 lots of minus 2 squared plus 5 lots of minus 2. 3 lots of minus 2 squared is, what's that? 3 times 4 is 12. Minus 10 is 2. All right. Now we have all the parts needed. Then put in this into that equation. Y equals minus 1 on f dash a. So minus, whoop, that's different. minus 1 on minus 7 is really just 1 on 7. Bracket. X take negative 2 is going to be x plus 5, close bracket, plus f of a. Now f of a is just 2, so plus 2. And we can tidy this if we particularly want, but, I mean, and then there's going to be like 5/7 plus 2. There is just fine for the equation, unless it asks us in the form of y equals mx plus c, but you guys can all get there from there. All right, so please have notes on the plan. The plan for each of these is f-x, f-a, f of a, you should have a pair of numbers, then use this trick to find y equals, and that will be the equation of the tangent. The problems will get more involved, but this is the fundamental starting point. All right, so if you have these notes, it's an excellent place to start for class. Thank you very much.